A car is traveling along a road winding around the seaside cliffs at 54 kilometers per hour. The road has an upward slope of 5 degrees to the horizontal. On a particularly sharp curve, the driver loses control, drives off the road, and becomes airborne. If the cliff is sheer so that it can be assumed to be vertical and is 40 meters above the ocean below, at what angle to the horizontal does it hit the water? Okay, so the first thing we gotta do is convert this 54 kilometers per hour into units of meters over seconds. So we know that this kilo is 1,000, so we can go ahead and add three zeros behind the 54. So now we have meters over hours, and we know that 1 hour equals 3,600 seconds. So when we divide that, we get units of meters over seconds. Okay, so now we converted it. Now we have to figure out the x and y components because it said it goes on an upward slope of 5 degrees. So we got to split up our velocity into x and y components. So to get our y component, we do sine of 5, and to get our x component, we do cosine of 5. Now when we plug that in, we get the velocity in the y direction is going to be 1.31 meters per second, and our velocity in the x direction equals 14.94 meters per second. Now, when solving this, we want to get our final velocity. And in order to do that, we have to figure out our final components for our x and y velocities. And once we have our x and y final velocities, we can figure out the angle of where the total velocity is going. So from that, we can go ahead and use this equation to solve for it. And one thing to note is this angle equals this angle. And because the question is asking for the horizontal to the ocean, um, we can, well, we're solving for this angle. Okay, so now that we got that out of the way, we can go ahead and use this kinematic equation to solve for our final velocity. So when we rearrange this, we get v2 equals the square root of v1 squared plus 2a delta x. And when we're solving for our velocity in the y direction, we get vy2. That equals the square root of 1.31 squared plus 2 times negative 9.81. We're going to multiply that by negative 40 because in our problem it says that the height of the cliff is 40 meters right here. And essentially, you're starting at a height of 0 and you're going down 40. So because you're going down, you're going to use the negative 40. So we're going to go ahead and add that negative 40, and we're going to go ahead and plug that into our calculator. So we get Vy2 equals 28.04 meters per second. Now we can go ahead and do the same thing to find our velocity in our x direction. So we're going to go ahead and do Vx2 equals the square root of 14.94 squared plus 2, and it's not accelerating in the x direction, so we can go ahead and multiply that by 0 and multiply that by delta x. And because we're multiplying by this 0, this whole thing cancels out. So when we go ahead and get rid of the square and the square root, our answer is just going to be 14.94. So from there, we have our x velocity and our y velocity. So what we can do now is make this bigger. We can go ahead and align it to our final velocity. So we have our 14.94 and our 28.04. And we can go ahead and solve for this angle. And in order to do that, we can use inverse tangent, and we can do opposite, which is a 28.04, over adjacent, which is the 14.94. And from there, once we plug it in, we can get a final answer of 61.95 degrees. So going into a calculator, we went ahead and converted the 54 kilometers per hour, and then we got our y value and our x value for our velocities. And from there, we used this kinematic equation to solve for the final velocities. And for this part right here, you're ending, you're going down 40. So this would become a negative and acceleration would be a negative. Now, for the velocity and x component, since you're multiplying this by zero acceleration, you can completely cancel this out, and then you're left with your initial velocity, which was 14.94. And lastly, since we have our velocity in the y component and velocity in the x component, we can plug that into inverse tangent to find our angle. So Vy over Vx, and we get 61.93. And that's our angle.